So now we're down to the point where we have to take off this coupler half right here, which I believe is going to be secured by this bolt right here. The seal that needs to be replaced is directly behind this. This is going to be the bearing cap that holds the input shaft bearing in place. And then of course the other seal that's leaking is this one here, and it's got a bearing cap on it as well. So I'm going to have to pull that off because the seal is not exposed. So we'll pull that off and see what we find under here to take care of that one. And at the same time, on the other end of the belly pump, there is where the drive shaft or the belly pump input shaft goes back into the torque tube to drive the belly pump. I'll go ahead and have to do exactly the same thing up there. Looks like there's a little wobble, a little bit of wear in that bearing there. I don't know that it's recommended or not, but what I'd like to do if I'm using a puller is I'll take whatever, if it works out that way, I'll go ahead and take and drill a little bit of a divot close to center as possible on that bolt that I'm going to be pressing against, because that'll give the pointed portion of your puller something to ride on and not slip out. Sometimes you'll see guys take an impact and shoot an impact right here, an air impact onto your puller, and what that'll get you is a lot of bent or broken flanges. If you have a tendency to do that, you're much better off taking the slow road. Here's our seal. Well, there's the bearing retainer and here's the seal. I'll be able to get those numbers off of this. There will probably be national numbers on this seal, and if not, I'll be able to transfer the existing numbers to get a national seal. The worst thing you'd have to do would be use a digital caliper and measure the opening that the seal fits into and measure the shaft, and then go with those dimensions and also the thickness of the seal or the width of the seal, and go with those three dimensions to come up with the comparable seal if the numbers don't cross-reference. Hey, good morning everyone, it's Tractorman 44. Now in the previous video we went ahead and split the tractor apart, the whole reason to replace some leaking seals. So this video here is going to be actually about removing the bearing caps, removing the bearing, because I think the bearing's got a little bit of a wobble in it. But removing the bearing cap, removing the bearing, and then of course removing the seals, and then figuring out how to get those replacement parts and pieces. So yeah, I forgot to tell you, this is a 1945 International or Farmall Model H. The national numbers, or the seal numbers, will be stamped in the perimeter of this greasy face. So once you get that done, to get these bearings out, we got to drive up this Woodruff key. So you drive up that Woodruff key, and I like to use a screwdriver the right size as the keyway, so you can reach down in there and kind of get it the rest of the way out. So we have to kind of clean that up a little bit and get ready to put it back together. Now this here has got a retention ring right here, so that whole bearing assembly should be coming out right now. It's free of the casting, came right out. So now we're going to move on down here to the output shaft through the belly pump. I got to pull this cover off here. It's going to be a bearing retention ring as well. Now what we got to do to back off this drive, it's actually threaded onto that counter shaft, or that shaft in there. So I've got my son up here holding back on the gear with the big driver. We'll put this big square drive screwdriver in there like that. And that's going to shock your hand a little bit, so kind of hold it securely but loosely at the same time. Let's go and let it roll around. So there's our drive. It's got a dual seal. It's got an inner seal and it's got an outer seal. That's interesting. Well, this bearing here is good and secure. This is nice. But that also would just slide right out. So now it's on about the business of cleanup, getting the seals out, get the seal numbers, and head to the supply house. I've got the shaft all shined up, cleaned up, and I've got an assembly lube that I've spread on that shaft and also on the inside of the bearing housing. This here is actually a magic lube. It's kind of impervious to moisture and things like that. It gives you a good sticky surface for your bearing race to slide on, and it's served me well over the years. There's also a product just called Assembly Lube. It's a real thick lubricant that I put in all the rod bearings, main bearings, all that stuff as the engine is being assembled. That'll work just fine in this case too. But at any rate, I've got that input shaft bearing right here ready to tap in, and it is definitely not what you would call an interference fit. An interference fit requires a press to press on, but this is a very tight fit, and it just won't slide right on with your fingers. So I use a piece of brass. This happens to be a small piece of brass pipe, and just gently tap on the inner race all the way around the perimeter. If you tap too much to one side or the other, it cocks the outer race in the opening and binds it up. We'll continue like this until we get up to the retainer. It'll come up flush with this right here. We'll go ahead and repair the gasket and put that bearing housing back on with the new seal. So here we are now. The bearing's tapped in all the way up to its hilt. You can see the shaft turns freely. The bearing rolls nicely in the race. It's got the pre-lube on it, so it's good to go. So now it's time to change the seals and put the bearing cap on with the new gasket. Well, I went ahead and pressed the new seal into the bearing cap. So now the next thing that we'll do will be to take the existing gasket. We're going to coat that gasket with a good Permatex sealer. Thin coat on both surfaces. If you notice on this bearing cap, there's a divot in the actual casting. If you notice, there's also a divot at the very bottom of this right here. That allows for the lubricant coming up and around the bearings to return. That's why this is positional. Should be marked with a up somewhere. I don't see an arrow or anything, but that should have been marked, I think. But it definitely is positional. This is just a gasket sealant. Now there are torque specs on every bolt, but if you don't have access to the torque specs, there's a general setting for the diameter of bolt. I'm thinking for an actual 3/8 thread, anywhere near or around 35 to 45 foot-pounds of torque would probably be adequate. Do not hold that to be true. I would have to check that. The very next thing now, we'll need to slide our coupling, our little coupling with the Woodruff key. So I've already shined up the Woodruff key. That'll slide right in here underneath, and then that coupling will go right on top of this right here, and that coupling is retained through the center with this retaining bolt and washer right there. Clean this keyway out as well, and of course I shined this all up because this is going to go on my seal surface. Right when I need the light, the battery goes dead. Keyway's in there, got a little bit of assembly lube on it. The lower shaft that drives the belly pump, I'm going to do exactly the same thing. This bearing sounded a lot better. I did not change the bearing. I think it's going to be an identical bearing number. In retrospect, I probably should have, but it doesn't have that telltale grind. Here's the part that's going to actually insert into the bearing retainer. And this one here is a double seal. If you look here, you can see a seal flush with this side turned to the inside. And also on the other side, there's a second seal that's flush with the inside flange and pointing to the inside. That's the way this is set up, the way it's designed. And this is also position sensitive too. It has to have this here in line with this over here, so it has to go on and just perfectly like this. This one actually is marked top. I just now saw that. When I lined up this weep hole with that right there, the top part is up above. That's good. Now if you look at this guy right here, you can see two distinct wear grooves, and I can feel it actually. Now that could be a bit of a problem. There's a company that I dealt with years ago called Ready Sleeve that makes a very thin, just a few thousandths thick bushing that you can sleeve or slide right over the top of a worn shaft, and it won't affect the diameter of the shaft to where the seal will still stretch enough to allow that to be installed, and then that will keep a worn shaft from leaking around that seal edge. The saving factor on this is these seals are different than the original ones insofar as the thickness and the placement of the sealing material against these grooves is slightly different. So I think I'm going to eke by and make it without leaking. That's very fortunate. I think that's going to work just fine. But at any rate, we have to orient that there. We got to put this other gasket back on again with the Permatech gasket sealer, and then we'll go ahead and torque these guys down too. You see, I've got the surface all scraped from all the debris and everything, you know, the years and years of grease and grime between those halves. I've scraped all that off of there, and then I've cleaned that surface with brake clean. I really like the brake clean. It really cuts the grease and gets that a nice pristine surface. So now I'm going to go ahead and treat this gasket. Of course, the gasket too is position sensitive. It has to align with this right here, and they in turn have to align with that. I'll have to get the torque wrench, put torque wrench on those as well. Probably going to be about 25 foot-pounds of torque. But then this here's the coupling that goes on, and this is a threaded coupling, so it's ready to slip right inside. I'm going to lubricate that just a little bit so we don't have a rough edge going through that brand new seal. Doesn't take much to lubricate it, but it doesn't take much to rip a new seal either. The engine rotating this direction right here, this is held on with a cap screw. This one tightens against rotation of the counter shaft down there. So it's automatically tightening in the direction it's rotating. So right now we're ready to go ahead and line up and reassemble the two sections. Then I can go ahead and worry about finishing the service of the internals of the transmission final drive. So that's where we're at right now, folks. Now, because I had this separated so far so I could get in here to do the work, I could strain pretty good, you know, and roll this thing backwards, but I don't see the need to do that, you know, because I just soon use a little bit of mechanical advantage. I can just do it slowly and methodical, and whenever I get up close, then go back to moving it by hand. But whenever we get up close, then we're going to have to go about the business of adjusting elevation to make sure both halves come together perfectly the way they need to. So this will go crooked a little bit. Remember, we've got our lineup pins here on the torque tube housing. So when those will line up perfectly with the holes in the transmission housing, we'll be good to go. Okay, you can see I've got the come along disconnected. I've got the mating halves, or the mating portions, really fairly close. And if you look, you can see we're just a little bit closer here together than we are there. But I've got my lineup punch in here, so my alignment is pretty close. As I'm going to draw these things together, and as long as that will start, that lineup pin will start into that hole, I think we'll be okay. I'll get that inserted in the hole, then we'll go ahead and adjust this height here. I think this has to come up just a little bit to close that gap. But I've already got the jack set underneath there to where I can incrementally raise that just ever so gentle. So I'm going to put the come along back on and pull just a couple strokes on that. Just gentle pull it in. I got my lineup punch in here in the hole. This has to go up just a little bit. You see our crack right here and right here. So the whole belly of the tractor needs to raise up just a little bit. So right here what I'm doing is I'm taking the stress off of the misalignment by elevating those jacks. And if you look right over my shoulder, you can see that crack getting smaller right there as I'm just elevating the two portions of the tractor. By using the lineup punch on this side right here, I was able to finagle a bolt into the other side. Then I could use pressure on one jack or the other in order to get the elevation correct. And if you look at my crack down here and here, it's ready to match up absolutely perfectly. So I'm going to draw these two bolts in right here, and the two lineup are already penetrating the points that they need to penetrate, and so the 4 remaining assembly bolts are up on the inside of the torque tube housing. That'll have to be fitted in next. Never draw stuff up completely tight. I don't anyway. If you draw it up too tight and it's off just a little bit, you can't hardly get the next bolt started. So I'd like to leave everything loose just a little bit to give it a little bit of flexibility. We'll go up in there and see if I can get them in. The halves are mated together. Got drive coupling connected up underneath here, and got all 6 assembly bolts and the alignment pins in and tightened up. So now I'm ready to go ahead and pull the transmission cover while I'm in the shop here. And once I get the transmission cover pulled off, then I'll go ahead and roll out and finish the transmission service, the transmission and final drive service. We're going to power wash all that, get all that nasty stuff I couldn't get out when I flushed with diesel fuel. But at least the splitting of the tractor and replacement of the bearings and the seals, that part's completely done. So we're good to go. That'll be the end of this one here. And you know what? This has been a fun one. This is Tractor Man 44, and I'm out of here, guys.